Bismillahirrahmanirrahim. This is October 2011, variant 41, question number 6, topic is work, power, energy. And topic is here, particle, if you read a question, so there are two straight paths, AB and BC. Okay, this angle is 5 degree, this angle is 1 degree, height is here 45. So this is 45, okay. And A to B speed is constant, so from here speed is constant. What is speed here? Same here. And speed constant means acceleration is equal to 0. Okay, maybe not used here, but anyway, just for knowledge. And work done by friction force from A to B is 360 kilojoules, kilo means into thousands. Okay. Work done by applied force is our question from A to B. So first part is very easy. We can use it. Now formula net work done by applied force, work done by frictional force is equal to kinetic energy plus potential energy at a top B last point minus kinetic energy plus potential energy at a start point A. But this and this cancel. Why they cancel? Because half mv square and half mv square both are same, so they cancel. Okay, and you know that potential energy and A with ground level, this is 0. This is 0, you know it. Okay, so work done by applied force, our question, work done by friction force is given 3640, and this is, we have it, mgh, mass is 1200, G is 10, and H is 45, because mentioned here 45. And now we can calculate even easily. So let's see. Okay, so the answer is, we just solve it and bring it there. So work done by applied force is 90 and 3 5 zeros. Okay. So joules, but we know kilojoules, so 3 gone, so 900 kilojoules. So first part is over, so first part finished. Okay. Second part is asking us, so first part is over, find work done by engine from A to B. Okay, done. Now part 2, the resistance of motion is constant throughout the whole journey. And what the part 2 plan is, he said that work done by driving force from B to C is given 1660 kilojoules. And 1660 and 3 more zeros, joules, okay, given. Now find speed at B, given that speed at B is given here 15 meter per second, and we need to show that speed is here 29.9, show it. So this is our task, okay? So let's try to prove it. Okay, so it means I will concentrate this time B to C, okay? But important things here, he said frictional force here and here same. But it does not mean that work done by friction force, this here and here same. No, reason because it depends upon two things. Friction force into distance. This is a less distance, the more distance. That is why here work done by friction force is more, here less. So I need to find here first of all what is the distance here, okay? So therefore that reason I need to find this triangle, and distance we need it. So let's see, this is a 5, okay, 45, and find distance AB, okay. So 90 degree opposite by hypotenuse is a sine theta, okay, sine phi, it goes there, it comes down, so AB is coming, so AB is 45 divided by sine phi, and my answer is 516.32. Similarly, I want to find this also, the longer one, okay, and let's see what is this distance. This is a BC, okay, and this is a 45, and this is a 1 degree. So opposite by hypotenuse BC give you sine theta, and BC is this goes there, and 45 divided by sine 1. Okay, this gives you 2578.44 meters. Okay, now we can see that this will help us. How help us? Because part number 2, if you look at carefully, what is work done there, friction force? We know it. So work done by friction force from A to B is 3, 6, and 4 zeros. But this is what friction force into distance. Okay, 3, 6, and 4 zeros. Okay, distance for the smaller path AB. This because AB is this. So if I divide this one, so friction force is coming 3, 6, and 4 zeros divided by 516.32. So let's see 3,003. Okay, 6,000. 0 extra divided 1.5 is okay. Point answer is coming here 697.24. This is a friction force. So which is constant. He said constant from A to B and B to C. So it means I can find easily now. Apply formula. Okay, what is the formula? Work done by applied force, work done by frictional force, kinetic energy plus potential energy, and a end spot CC, and minus kinetic energy plus potential energy and a start spot B. Okay, so now this is given by him. So 1, 6, this is given by him 1, 6, 6, and 4 zeros. Okay, and this is, we know friction force is 697.24 into distance, and distance is BC we have here. So 2574.44. So this will give us this thing, okay? And now I can find this one also. What is the K at C is my task. So half mv square, half into m, mass is a 1200, V is VC. VC my target, leave it. VC square, and ground, this is 0. So here 0. So minus, open the bracket, half mv square, m is this, and vb is 15 square. Okay, minus into minus, plus minus plus minus, and mgh. And what is mass? 1200, g is 10, and height of this one is 45. So I do 45. Okay, so I will calculate and get VC, and you can do calculation. I think easy, not a hard job. Or okay, just 1, 6, 6, 1, 2, 3, 4 minus 9, 690, 697.24 times 2, 2578.44. Left hand side is coming minus 13779.1, and right side is coming. This is a 600 VC square. This is a, is a half into 1200 into 15 square, and plus 1200 and into 45. It is coming 675,000. It goes there. So, and then divide by 60. So it means I'm writing directly. Okay. So 675,000 minus 13791.51 by 60, 600, sorry, and equal to VC square. VC will becomes 29.9 meter per second. So proved. So this is a way to prove it. Okay, let's go. Okay, last part is here. The driving force at B is 1.5 times driving force C is given the question. So force FB is 1.5 times 2 of C. Ratio of the power to B to find ratio of power C is question. So ratio means dividing. So power at B I capital and C down. So formula power F into V. So I found both. Okay, and then divide them. So let's see what happens then. Power at B is what? Force at B. So 1.5 times 2 FC, and into speed of B is here 15. So I got this, and then divide the power of C, and power of C is what? Force at C is a force of C, and velocity of C is 29.9, and it is cancelled, and I can get my answer in